Hello student. Today we are going to start with one of the chapter of paper 1 and a very important chapter of physical chemistry, that is solution and colligative property. Now first of all, about the chapter, it's a simple chapter with lots of numerical, and the chapter is actually divided in two parts: solution and colligative property. Now we'll first go through with the solution, and then at the later part of the chapter we'll be studying colligative property. Now first of all, what is solution? Actually, solution is a mixture of solute and solvent. Let's take one example. Suppose I take a beaker and add some amount of water, and now in this beaker I add sugar, right? Now tell me one thing. Suppose if the sugar get dissolved in this water, we'll call it a solution. But if it does not dissolve, then we will not call it a solution. Okay. Now you tell me one thing. In this, what is solute and what is solvent? Yes, you're correct. Sugar is solute and this water is a solvent. So how we defined solution, solute and solvent? Okay, we see the definition part of that and we all understood also. Solution is defined as homogeneous mixture of solute and solvent, right? How we define solute? So tell me one thing, student. Tell me one thing over here. In this solution, we have taken sugar and water. In this solution, what is present in small amount? Obviously sugar. Sugar is present in small amount, right? And water is present in large amount. Okay. Whatever is present in a small amount in a solution is called solute. Means solute is something which is always present in small amount, right? And solvent is something which is present in large amount in a solution. Okay, so if I have defined what is solution? Solution is a homogeneous mixture of solute and solvent. Solute is the one which is present in small amount. Solvent is the one which is present in large amount. Okay, let's take an example. Suppose I say I have 20% of ethanol solution. So in that, if I say 20% of ethanol solution, that means 20 ml of ethanol is present and 80 ml of water is present. So 20 ml of ethanol, this is present in a small quantity. That means it is a solute. Water is present 80 ml. That means it is solvent. Correct? But now, important one. But if I take, suppose I say 80% of ethanol. If I take 80% of ethanol, then it will be 80 ml of ethanol and 20 ml of water. Now student, understand this. Now this ethanol will be solvent because it is present in large amount, and this 20 ml will be water, right, and it will be called as solute. So understand this. I hope this is clear. Now, so we understand what is solute, what is solvent, and what is solution. Now, if a solution is there, then every solution has certain concentration. All right, every solution has certain concentration. For example, if I'm talking about, suppose I take a room, this is one room, right? If I have to find out its distance from one part to the other, okay, and if I ask you to find out, you can express this distance in feet, in meters, in centimeters, right? I mean, there are various ways of giving information about this distance, right? Similarly, if I take a solution has its concentration. Every solution has some concentration, and that concentration can be expressed in many ways. Okay, let's talk about that concentration. Now this concentration can be expressed in many ways, and I divide this into two parts. One part I called as group A, other part I called as group B. Now on what basis I'm classifying this, I will let you know. Okay, but before that, let's see which are the concentration present. First one is one very important thing. I'm classifying this on the basis of volume, and this group I'm classifying this on the basis of mass, right? This on the basis of volume, this on the basis of mass. Okay, now the first is volume by volume percentage. Second one is weight by volume percentage. Third one, and the very important one, is molarity. And the fourth one is normality. In group B, first one is weight by weight percentage. Second one is mole fraction. Third one is molality. This one is molarity, this one is molality. Okay, this is denoted by capital M, this one is denoted by small m, right? Mole fraction, it is denoted by letter X. Normality is denoted by letter capital N. Okay, one more. This is ppm. What is this ppm? ppm is part per million. Okay, now student, when I say concentration, see, we are talking about a binary solution. What is binary solution? Binary solution means if a solution consists of only two components, one is solute, other one is solvent, then such solution is called as binary solution. So here we are talking about only two, that is binary solution. Now when I say concentration, concentration is actually a ratio. When I say a ratio, it always consists of a numerator and one is denominator, right? Numerator means I normally talk, generally, not always, but normally I am talking about solute. But when I talk about denominator, that means I am either talking of solvent or I am talking about solution. So whenever I express some concentration, it will have one numerator and denominator, right? Again, I'm saying numerator normally gives information about solute, and denominator normally gives information about solvent and solution. Not always, but this is most of the time. Okay, is it clear? Now we start with group 1. Now we start with the group 1. Okay, in group 1 or group A, first we have to understand volume by volume percentage. Volume by volume percentage. Now volume by volume percentage. Okay, student, one more thing I want to tell you before this, on what is the basis for this, how why I have classified this into group A and group B. See, a very important one. Group A, here they all are based, means all their formulas, they are expressed in volume. In group B, all the formulas are expressed in mass. Okay, anything which is based on volume changes if the temperature changes. That means all these things, they are all temperature dependent. They are all temperature dependent. When I say temperature dependent, means if I change the temperature, these concentration will change, although the substance will remain same. Right. For example, suppose I say, suppose this is something which I have. If I heat this, it will expand. If it expands, its volume will change. If volume is changed, then obviously the concentration will change. But when I heat this, the mass is not going to change. That means all those concentration which depends upon mass, they will not change if the temperature changes. That means they are temperature independent. Are you getting? They are temperature independent. Now student, sometimes the question can come like this. Question can come like this. Out of the following concentration, which are temperature dependent. Out of the following concentration, which are temperature or which is temperature dependent. Which is temperature dependent. Option they may give you like molarity. B option, suppose they give you molarity. C option, they give you mole fraction. D option, suppose they give you weight by weight percentage. Out of the following, which following concentration which is temperature dependent, means which is concentration depends upon temperature. That means if I just change the temperature, which concentration is going to change? Obviously the answer is molarity, because it is volume dependent. All these threes are weight dependent. I hope this is clear. Understood? So that's a very important point. We should understand group A and group B is divided on the basis of volume and weight, whichever the concentration depends upon volume, they are temperature dependent. That means if I change the temperature, the volume will change. That means concentration will change. But group B, they are temperature independent. Understood? Okay. Now we'll move to group A now. In that, first one is volume by volume percentage. Now student, we'll understand also this, and very important, we have to remember the formulas, because in this chapter formulas are very important. If you remember the formulas at any point of time, means whenever your teacher asks the question or asks any formulas, you should be able to give the answer. Or when your friend asks or when your parents ask, if you remember the formula at that point of time, that means you're prepared. Okay, so put attention on the formulas, try to understand it also. Now, volume by volume percentage. The formula is volume of solute. Both is volume, this is numerator, this is denominator. Volume of solute expressed. See, when I take a solute volume, it has certain constant, it has certain units. The unit of this will be ml. Volume of solute, it is expressed in ml. Volume of solution, understand student, volume of solution, it is also expressed in ml, because it is percentage multiplied by 100. Okay, now if I have to define this, what is the definition of volume by volume percentage? It is defined as volume of solute present per 100 ml of solution. Understand student, it's a solution present per ml of a per 100 ml of a solution. For example, if I say I have taken 80 ml of water, in that I add 20 ml of alcohol, right? Then the total is how much? 100 ml. In that 100 ml, 20 ml is alcohol, right? Are you getting that? That means, see, whenever I have to, definition says that you have to always define in terms of 100 ml. If I have not taken 100 ml, suppose I have taken 10 ml only, but then also you have to find, or I have to define in terms of 100 ml. Are you getting that? We'll understand this for example, don't worry. When we solve the question, we understand better. Now, for time being, I hope this is clear. The formula is clear, volume by volume. Okay. Now, a student, because we write the formula many times, it is not advisable to write this formula like this. So now we make one rule. Rule is, whenever I talk about solute, okay, I will express this either in the terms of B or in the terms of letter number, that is 2. When I take solvent, I will either express this as A or 1, and solution will write a solution only. Okay, what I mean to say, understand. Suppose I have to write a volume of solute. Instead of writing volume of solute, I will just write V2. So 2 means solute, V means volume. So this is volume of solute. Alright, volume of solution, but we have volume of solvent. So volume of solvent plus volume of solute will become volume of a solution, because solution is the solute plus solvent. So solvent plus solute added gives volume of a solution. Clear? Okay, and multiply by 100, and this will be volume by volume percentage. This is our formula. Clear, student? Okay, so whenever I write B or 2, that means I'm writing for the solute. I can write here, suppose I write, if I write W2, how are you going to read this? This is weight of solute. If I write W1, this is weight of solvent. If I add this, this is a weight of a solution, right? Now student, we solve one question based on that. Okay, now question is, for example, 30 ml of ethanol is present in is present in 300 ml of aqueous solution. Find volume by volume percentage. Suppose this is a question, right? Now student, volume by volume percentage. What is you can see the formula V2. What is V2? V2 is the volume of solute. Here solute is the ethanol, and when I say aqueous solution, that means solvent is water, right? You're getting that? So 30 ml of ethanol is present. That means volume of solute will be 30 ml. Now 300, what is this 300? Is this a volume of solvent or it is a volume of solution? Yes, it is a volume of a solution. That means I will write here 300 because the formula is volume of solution. I have to write volume of solution. This is also in ml. Understand student, it has to be in ml. Suppose it is given in liter, then we have to convert that liter into ml. So multiply by 100, right? 1, 2, 1, 2, 3 tens are. So the percentage is 10%. I hope you understood. So volume by volume percentage is 10. Clear? Now, one more question we'll be solving on the basis of that. The question is, how many ml of ethanol should be added in 200 ml of water to obtain a solution containing 80% volume by volume of solvent. Student, my advice will be pause the video, try to solve their own self, try it first. After doing that, then come back and see the video. Okay, hoping that you have completed, and now we'll move further. Student, we know the formula. Volume by volume percentage is equal to volume of solute, volume of solvent plus volume of solute multiplied by 100. This is the formula. V2 upon V1 plus V2 into 100. Now, how many ml of ethanol should be added in 200 ml of water? What this 200 ml of water, that means they have given us the volume of solvent, correct? Volume of solvent is given. That means they have given V1 ka value. V1 ka value is 200. V2, how many ml of ethanol should be added? Means they have asked us V2. So this is what they have asked us. So here also V2 into 100. Now very important. Tell me, what is the percentage of V by V is given to you? It is given here, right? 80%. So should we write here 80? Right? Wrong. Yes, it's wrong. Why it is wrong? Because to understand, this is very, very important. Very important. 80% volume by volume of solvent it has mentioned. When we have C, this formula is V by V. What is V there? This is volume of solute and this is volume of solvent. But when I say volume of solvent, that means in the numerator they have not mentioned the volume of solute. They have mentioned volume of solvent. Understood? See, if understand this, if I say volume by volume of solute is 80, then we could have written 80 over here. But this is volume by volume of solvent. So, but the formula is volume by volume of solute, right? So, I mean, what we are going to get over here? So, it will be, first understand this, 100 minus 80 will be 20, right? This 20 is volume by volume of solute. So here we are going to write 20. I hope you understood this. Understand? I'm saying this. Volume by volume, this formula is volume by volume of solute. But here they have mentioned volume by volume of solvent. Right? So here will come 20. Okay, now you can easily solve this. 20. This will become 5. Okay. So 5v2 will be 200 plus v2. This comes over here, 4v2, that is 200. So v2 will be 200 by 4. So this is 25. So v2 is 25 ml. Is it clear? Oh, I think I've done some mistake. 4 5s, it's 50. Sorry, V2 is 50 ml. Got that? I hope this is clear. So this was the first one, that is volume by volume. Second question, student. Second is weight by volume percentage. Now the formula is going to be same. What is this W? This W is weight. I'm directly writing now. This is weight of solute. Now this one is volume of solution. Correct? This is volume of solution multiplied by 100 because it is percentage. Now weight of solute. What will be the unit? Weight, is it gram, kilogram? But it's gram, because when I write ml, it's a CGS unit, so I have to take the CGS unit of a gram, weight, that is gram, right? Volume of solution, this is in ml. Understood? And very important, understand one thing. When I say volume of a solution, if weight and volume cannot be added, because additive properties only when they have same units, so we can't add this over here. This is an important part. Now student, we'll solve one question based on this, and that will give you better idea. Question is, how many gram of NaOH is required to prepare 2.5 liter of solution of concentration 5%, weight by volume. How many gram of NaOH is required to prepare 2.5 liter of solution concentration, weight by volume, that is 5%. Now first write the formula. Weight by volume percentage is weight of solute in gram, volume of solution multiplied by 100. Understand student? They have asked us how many gram of NaOH is required. Means they have asked us to find out W2. This is what we have to find out. Volume of solution, they have given 2.5 liter. 2.5 liter, if ml, you write 2500 ml, right? This is in grams multiplied by 100, and here is weight by volume percentage, that is 5. Understood? Now 1 2 1 2 25 into 5. W2 is 25 into 5, that is 125 gram. Got it? Clear, student? Simple? Okay, now moving to the next concentration term, and it's very important. That is molarity. Third one, molarity, capital M. Okay, now how we define molarity? See, this is what you are actually also studied in 11th standard. Okay, if you have understood, well enough. If not, try here. Molarity is denoted by capital M, and the formula is, it is defined as ratio of number of moles of solute upon volume of solution in liters, or I can write dm cube. Dm cube and liters are same. I hope you know, students. Now student, molarity actually is a ratio of moles upon volume of solution. See, suppose I say, we have to understand this very well. Suppose I say prepare a solution of urea by putting 60 gram and make a 1 liter solution. Okay, 60 gram of urea. Right, we can make it. And let's understand this. Suppose I say I have taken one vessel. In this I put 60 gram of urea. This is nothing but 60 gram of urea, and suppose the marking is here is 1 liter. I add water, water is added, and I make a solution till here. That means total solution is 1 liter, and that 60 gram of urea is there. Okay, that's simple. We can prepare it. But molarity says, don't tell me in the terms of weight, tell me in the terms of moles. So is it possible that I can convert weight into moles? Because molarity says give me information in moles, not in weight. Yes, we have an idea to convert weight, or we have a formula to convert weight into moles. You have studied this in 11th standard, some basic concept of chemistry. Number of moles, let's say the formula, number of moles is weight of solute, or not weight of solute, weight of anything I can say. Suppose number of moles is weight upon molar mass. This is the formula for number of moles, weight upon molar mass. Now when I say urea, I have taken 60 gram of urea, correct? I have to convert that gram into moles. So moles, I take 60 gram, and urea. What is the molar mass of urea? Formula of urea is CONH2 twice, right? Nitrogen is 14 plus 2 is 16, right? 16 2s are 32 plus carbon is 12, oxygen is 16. So 6 plus 2, 8 plus 2, 10, 1, 2, 5, 6, 60. So I hope you understood this. Molar mass is 60. That means I have 1 mole. That means I have 1 mole of solute in 1 liter. Are you getting that? I have 1 mole of solute in 1 liter of a solution. So the number of moles of solute, how much moles I have? 1 mole. In how much? 1 liter. So what is molarity? 1. Simple. Right? Student, instead of giving information in weight, give information in moles. That is what is molarity. I hope you understood, and I think it's a simple one. Okay, so I hope you understood this formula, right? So simple, molarity means 1 लीटर में कितने मोल्स प्रेजेंट है, एज सिंपल एज दिस. यहाँ 1 लीटर में 60 ग्राम था, राइट, बट व्हाट वी नीड इज 1 लीटर में कितने मोल्स प्रेजेंट है. तो 1 लीटर में कितने मोल्स हैं, 1 मोल. सो द मोलारिटी इज 1, राइट. सो नाउ द formula is molarity, number of moles of solute. I write as N2, number of moles of solute, because 2 stands for solute, upon volume of solution, and that too in liter or dm3, right? So this is one formula. Okay, now moving further, one more formula, molarity. See, number of moles of solute can be written as weight of solute upon molecular weight of solute, or molar mass of solute, right? So instead of N2, can I write V2 by M2? So that is W2 by M2, W2 by M2, this is N2, and here it's a volume of solution. Understand, student, suppose if the volume of solution is given in ml, for example, if I say 500, some solute is present in 500 ml of solution, right? You have 500 ml of solution, but according to definition I need that in liter, right? I need in liter, not in ml. So that ml, 500 ml में कितना लीटर होता है? 500 ml मतलब कितना लीटर? Obviously half liter, right? It's a half liter. 500 ml means half liter. So how I will get half liter? Half liter I will get if I divide this by 1000, because 1 liter has 1000 ml. So if I have to convert this, I have to divide by 1000. So when I divide by 1000, I will get what? Half, right? That means 500 ml, if I have to convert in liter, I have to divide it by 1000. Okay, so if the volume of solution is given in ml, but if I have to convert this into liter, then I have to divide this by 1000. I hope you understood, student. So now it is converted into liter, but denominator is there, it will become numerator. If I divide denominator by something, that becomes numerator. So the final formula which I'll be getting is molarity is weight of solute, molecular weight of solute, volume of solution, if it is given in ml, multiplied by 1000. This one is molarity. This is what? Molarity. Okay, any doubts? We solve one question based on that. Now suppose I say 30 gram, question is 30 gram of urea is present in 250 gram of solution. Find molarity. Suppose this is a question, right? 30 gram of urea is present in 250 gram of a solution. Find molarity. Molarity is, let's write the formula: weight of solute, molecular weight of solute, volume of solution, multiply by 1000. This is the formula. Now weight of solute, this is given, that is 30 gram of urea. So it is 30. Molecular mass of urea, we have just here, we have find that molar mass of urea is 60. Okay, can you see? Molar mass is 60. So I'm directly writing here molar mass is 60, volume of solution is 250, not gram, 30 gram of urea, volume of solution is 250 ml. I write here. So it is 250 ml, and here multiply by 1000. Okay, so 250 4s are 1000. Here it get cancelled. 3 2s are and 2 2s are. So molarity is 2 molar. Molarity is how much? 2 molar. What is this molar? Molar is actually a unit of molarity. Let's talk about the unit. Okay, there are 2 units of molarity. First unit is molar and second unit it depends upon the formula. Let's understand over here. Number of moles. So what will the unit of moles? Mole. Volume of solution, it is in what? dm cube. So what is the unit of molarity? Mole per dm cube. So the unit of molarity is mole per dm cube. Got that? Done? Right? So this is what molarity is. See, we can solve the number of problems based on that, but we can solve it later part of the chapter. Initially, let's understand what the concentration terms is. Now, next part is student normality. Next part is normality. Now, normality is denoted by capital N, and this is the fourth one and the last part of group A, that is volume term. Now student, normality, if I write in a formula in a very simple manner, normality is molarity into n factor. Molarity into n factor. Now we have to understand what is n factor. Molarity, there is a formula of molarity we can put and we can find n factor. But let's actually the actual definition of normality we'll understand later on. But first let's understand what is n factor. Okay, n factor. In some book it is also written as valency factor, so don't get confused. It can write as a valency factor, but I will mention here n factor. So what is n factor? N factor can be described for acids, for bases, for salts, for strong, for oxidizing and reducing agent. But let's talk for acid. Okay. Now n factor for acid. Let's take example. Certain example. First example, I talk about HCl. Now, what is the? If I put HCl in water, okay. So HCl will dissociate as H plus plus Cl minus. That means this one hydrogen is replaceable in HCl, right? So the n factor for HCl will be 1 because it consists of one replaceable hydrogen. Understand student, it's a replaceable hydrogen. Okay. Now, if I take H2SO4, H2SO4 will dissociate as 2H plus SO4 minus 2. Right. So what will the n factor for this? Because it can replace 2 hydrogen, so the n factor will be 2. Clear? If I take H3PO4, it will dissociate to give 3H plus PO4 minus 3. So the n factor for this is 3. Clear? Right. Now very important. If I take acetic acid, CH3COOH, right? How many? What will be the n factor for this? Now students, understand this is very important. Here I have 3 hydrogen, n factor is 3. I have 2 hydrogen, n factor is 2. I have 1 hydrogen, n factor is 1. But here I have 3 hydrogen over here, 1 hydrogen over here. Right? The n factor will not be 4 because it will dissociate like this: H plus CH3COO minus. So it out of 4 hydrogen atom, only 1 hydrogen atom is replaceable. So that's the reason here the n factor will be only 1. I hope you understood this. Now, obviously the question is how we हमको कैसे समझेगा कि इसका n factor 1 है 4 नहीं. See, that depends and you can understand only if you know the structure. If I draw the structure of acetic acid, so acetic acid is CH3, C double bond O, OH, and here 3 hydrogen is present, right? Now student, if you see this hydrogen, this oxygen is partially negative, this hydrogen is partially positive, right? So this hydrogen is said to be acidic hydrogen. You might have studied this in organic chemistry. If you don't know what is acidic hydrogen, I make you understand, don't worry. If a hydrogen, precisely hydrogen I'm talking, if a hydrogen is attached to the electronegative atom, any electronegative atom, then that hydrogen become acidic. Here also the hydrogen is present, but this hydrogen is present to carbon, right? And carbon is not that electronegative, right? So that's the reason these 3 hydrogen are not acidic. Only this hydrogen is acidic. That's why the n factor is 1. I hope you understand, right? And for this acid, it is called basicity. When we find how much H is present, that factor is called as basicity, also called as basicity. Got that? Okay. Moving further, we have studied for acid. Now we are going to study for base. For base, we have to find replaceable OH minus. Example, that's a very simple one. Some complicated part is also there, but that we'll be studying later on when we solve the MCQs based on this chapter. NaOH will become Na plus OH minus, right? If I take suppose MgOH twice, it is going to dissociate as Mg plus 2OH minus. So here only one OH is present, so n factor is 1. Here 2 OH is present and n factor is 2. Got that? Okay. Next one. For salt, what is the n factor for salt? Let's understand this. Suppose I take NaCl. If I dissociate NaCl, it will become Na plus and Cl minus. Okay. So cation, positive ion, anion, negative ion. The charge present on the salt is actually an n factor. Charge present on a salt is a n factor, right? Now student, here the n factor will be 1. Question comes, so should we look the charge on cation or anion? But either, you can look for either. You can, it is going to be same. Na plus 1, Cl minus 1. If I say here this is plus 1 ka charge, here so it's minus 1 ka charge. So the charge present is a n factor. If I take MgCl2, this is going to dissociate as Mg plus 2Cl minus. Now the charge on this is plus 2, so n factor is 2. But it says sir, here charge is 1, but the net charge is minus 2. One charge is present on, understood, one charge is present right on chlorine, but I have 2 chlorine, so the net charge is 2. So I hope this is clear, right? Is it clear, student? Okay. Now next one, for oxidizing agent or reducing agent. Okay, I'll explain this in very short. Let's understand. Suppose I say I have KMnO4, right? And this KMnO4 became Mn plus 2 and some XYZ whatever. Okay, we're not bothered about that. Now student, understand. The charge on this Mn is plus 2, right? The charge on this Mn is plus 2. What is the charge on this Mn? You might have studied this in redox reaction, right? Let's understand this. Oxygen is how much? Every oxygen is considered -2. Potassium is alkali metal. It is carrying +1 ka charge. Mn I have to find out. Okay. Now suppose I say this is +1 Mn. I take at X. -2 is for one oxygen, but I have 4 oxygen, so net oxygen charge will be -8, and the net charge will be 0. Redox reaction, if you remember. So X ka value is how much? +7, right? Getting this? Okay. So the charge on Mn is +7, and here the charge on Mn is +2. So what is the difference between this? Difference between +7 to +2 is 5, right? So this 5 is your n factor. I hope you're getting this point. So n factor can be described for acid, can be for bases, can be for salt, can be oxidizing as well as reducing agent. Okay, here it is Mn is converting from +7 to +2, but itself it is getting reduced, means it is acting as oxidizing agent. Okay, student. Now we understood what is n factor. Okay. Now moving further, we'll see what is the formula. We'll revisit the formula of normality. Normality is equal to molarity into n factor. Normality, molarity can be written as weight of solute, molecular weight of solute, volume of solution multiplied by 1000. This is molarity, and here it's the n factor. It's a n factor, right? So these are the formulas which we'll be using. Okay, so now let's see one question. Question is 9.8 gram of H2SO4 is present in 250 ml of solution. Find normality. Suppose this is a question, right? Now student, I'll be using this formula. Okay, normality is equal to, what is weight of solute? 9.8 gram. 9.8 gram of solute multiply by 1000 molar mass of H2SO4. Let's see, H2SO4, hydrogen is how much? 2, sulfur is 32, oxygen 16, 16 fours are, oxygen 16, 16 fours are 64, right? 4 plus 2 and 2, 4 plus 2 6, 6 plus 2 8, and 6 plus 3 9, 98. So molar mass is 98 and 250 ml. Very important. Sulfuric acid. What is the n factor for sulfuric acid? We have just done here, right? For sulfuric acid, n factor is how much? 2. Okay, so the n factor for sulfuric acid is 2, correct? Now just solve this. 250 4 right? 9.8, this become 10, right? Then this become 4 to the 8, 8 by 10, that is 0.8. So normality is 0.8 normal. Understand student, we have to one more thing, unit, we have to understand the unit. Unit for normality is normal, or we just write as what? N. Okay, clear? That is what normality. Now student, this was the simplest formula for normality, but actual definition of normality is somewhat different. Okay, And if you have to understand the actual part of normality, okay, let's do it. Let's understand that also. But if you remember this formula, that is, you can solve easily the question which comes on that. Now, student, normality. We will see one more formula for normality. It appears to be difficult, but at the end, by the end of the explanation, at the end of the explanation, you will find, I think it will find simple. So normality is number of gram equivalent of solute. I'll make you understand what is all these things. Number of gram equivalent of a solute upon volume of solution in dm cube. Now if you compare this normality and molarity, molarity was number of moles of solute. Remember what was 1 minute, I show to you. See here, number of gram equivalent of a solute, volume of solution dm cube. Here also volume of solution dm cube. But in molarity there is number of moles of solute, and normality is number of gram equivalent of a solute. Is it clear? Okay, now let's understand number of gram equivalent of solute. Okay, so you understood what is the volume of solution dm cube. You have to understand what is number of gram equivalent of solute. Okay, clear? Now number of gram equivalent of solute, number of gram equivalent of solute is nothing but weight of solute upon equivalent weight of solute. Weight of solute upon equivalent weight of solute. Okay, now question is, we understand what is weight of solute, but what is equivalent weight of solute? Let's understand. Don't worry, have patience. At the end you'll understand everything. Equivalent weight of solute is molecular weight of solute upon n factor. Now student, we have understood what is n factor. Okay, now let's revisit the same question which I have done over here. Okay, 9.8 gram of sulfuric acid is present in 250 ml of solution. Find normality. Okay, getting that? So let's same question. 9.8 gram of H2SO4 is present in how much? Is present 250 ml of solution. Is present in 250 ml of solution. Find normality. Okay, now let's see 9.8 gram. Now first see, if I have to find number of gram equivalent of solute, I need to find what is equivalent weight, because weight is given, right? Let's see, suppose I have to find a number of gram equivalent of solute, volume of solution in dm cube. I don't know what is gram equivalent of solute, but I know what is volume of solution in dm cube. Volume of solution is how much? 250. So I can write here 250. Okay, getting this? Now next is, if I have to find number of gram equivalent solute, I need weight of solute upon equivalent weight. Weight of solute is given. Weight of solute is 9.8. So I know this, what is 9.8, but I don't know what is equivalent weight, right? Equivalent weight of solute can be found if I know what is molecular weight of solute. Solute is sulfuric acid. We have find molecular weight is 98, and n factor of sulfuric acid is 2. We have just done before. So it is sulfuric is 2. So this become how much? 49. So equivalent weight of solute is 49. Equivalent of solute, I can write here 49. Right? Okay. And this will become 0.2. Correct? This become 0.2. and this 0.2 is number, I have here 0.2 over here, right, because this is number of gram equivalent of solute, 0.2, and here because it is given in ml, I multiply by 1000. So 250 fossa, and 0.2 into 4 is 0.8 normal, right, and that is here also. Now student, let's understand this, because sometimes the student feel difficult about this. See, it's not that difficult if you understand this. See here, here if we compare this with the molarity, we easily understand that volume of solution dm cube is similar in both, only the difference is this much. Okay, now number of gram of solute, right, it's a weight of solute upon equivalent weight. Now student, understand this. When we have studied moles, what is the formula for moles? Moles का क्या formula था? Weight upon molecular weight, right now. But when we have to find gram equivalent of solute, instead of weight upon molecular weight, we are writing weight upon equivalent weight. Means only difference is that कि molecular weight की जगह हम लोग क्या लिख रहे हैं? Equivalent weight, right? Clear? And when I say equivalent weight क्या है, तो molecular weight of solute upon n factor. See student, n factor is 2 for sulfuric acid. It is not going to change. It may change if the sometime it may change when the depends upon the problem, but most of the time molecular n factor for sulfuric acid is 2. It will remain same. Molecular weight of sulfuric acid will remain 98 always. Even we have studied the 98, right? You are studying 98. Your son will also study it as 98. Means it is not going to change, right? So molecular weight will remain 98. N factor will remain same, right? So this 49 is not going to change. Means equivalent weight of sulfuric acid will always remain 49. Okay, so if you remember directly it is a 49, so you can put over here, right? Okay, weight of solute is given, we can solve that, 9.8, and thus we can easily solve this. Okay, so it will be better if you remember this formula also. So student, here we have completed group A. Now group B we will be doing in the next video lecture. By the time, revise this on the daily basis, at least the formulas, solve numerical based on that, right? The numericals may be from a textbook or any other book. Try to find it out. Okay, thank you.